Hi everyone, welcome. In this video we are going to talk about the solution of linked list Hyderabad Best Coder Round 2. So we will see step by step how to solve the problem from scratch to end. So first problem we are going to look at is disciplined animal of Ringmaster. It had 20 as a score, it was easy, and this is the success rate. That means 53 people attempted it and 11 were able to solve it. And we can see like this is second highest success rate. The first was Gabbar is back. So let's start solving it. And now we can see here what problem is trying to say. Let's directly jump on to input format. It says first line contains n, which is an integer that tells how many animals Ringmaster has. This problem has a story which I guess most of the people have read. The story is simple. An animal is coming and he is smart enough that he is sitting in a sorted order. So animal can be cat, can be dog, can be zebra, lion. So if cat comes first and then dog comes, dog will sit after the cat. If zebra comes after, it will sit after the dog because they are sorted in dictionary order. Now if lion comes, lion will sit between dog and zebra because L comes in dictionary order after D and it comes before Z. So n will be given in the first line. The next n lines will contain the animals in sequence in which they are coming on. So our task is simple. Given this input, we have to convert it into output, which says based on the given order of elements, we have to output n lines where each line of output prints the three parts of every animal. First, who is the current animal? Like that. If dog is coming second, dog is the current element. Its left neighbor is cat, right neighbor is zebra. So previous neighbor and next neighbor we have to print. So we have to solve this problem by writing the necessary functions. Mostly the output function is already given to us, which is printing this list. So we have to take this input and we have to create the linked list. That is what the problem is. Here at the bottom we can see some code is already given, which is uneditable. At the bottom if we come, this is also given to us, which is uneditable. Main is calling a function create list from input. Then main calls print with neighbors. So print with neighbors is already given. We have to write the code for this function create list from input. So this is something that we have to do. Now we had two language choices. We can go with C or we can go with C++. Since most of the people opted C, let's see this solution in C code. So we change it to C. Let's go and switch our view to side by side view, because if we click this, we can see code on the right side, the problem statement on the left side. This way we can write our code step by step. So let's begin by converting the input to output. Now first line it says it contains n as an integer. So let's remove this comments. So first algorithm will say read n. After we have read n, what should we do? We should read next n lines. So that means next n strings we have to read. This is the sample input. Read 4 and then we have to read cat, dog, bear, crocodile. So after reading n, run a loop n times, and every time in this loop read animal name. And after reading the animal name, what we should do is we should insert in list in sorted order. So this is what we have to fill. Once we do that, I think we will be all set to say we have solved the problem. Now if we have to create a list, okay, let's do step by step. Let's convert our comments into code. Now if we have to read n, we can say scanf %d and we can say n. Ideally we have to say ampersand n. Now since we are using n as a variable name, we should first declare it as well. So let's go here and we declare. Now one tip to be cautious is people should not use the printf here like enter n. This is a programming style that we learn in college, but in programming context, if we use printf, this line will be written on output and this will affect this output. So ideally in context, we should never ever use the printf unnecessarily, because otherwise that will appear in the output. So I removed that. That is a mistake that most of people had made. Okay, so now we have read n. Another thing is after that we are reading a string. Now if you see the input, 4 is the input, and after that there will be a new line, because new line takes the cat in next line. So what we want to do is, if we do scanf in the loop, scanf %s, that new line will be read as the first string, and we don't want that to happen. So let me put a /n over here. This is to avoid reading /n as new string. So this is another thing to keep in mind. Now we have to run a loop n times. So we'll say for I equals 1, I less than equal to n, I plus plus, and inside the loop what we will do is we will perform these operations. And now let's start reading the animal name. Now before we move ahead, we should also see that we are using I, so I should be declared here. Now we are reading animal name, so we'll do scanf %s. Here also we'll put a /n, so that we can also consume the /n after cat. And this we will read in, let's say, an, which is animal name. So let's declare animal name also, and let's make it, see here it is given as 31, so max animal name size is 30 that is supported. So we'll do this. Okay, so after we read the name, now we have to do the insertion. Now this was the main exercise. We have to write the insertion code. So let me say we will write a function insert sorted. Now where are we inserting? We are typically inserting in a linked list, so we should give the head of the linked list in which we are inserting, and we should give the element that we are inserting. So this will be given a head and a value. We should do the insertion in the linked list, and this will return us the new head. Now why will there be a need to return new head is because initially if the list is empty and if we are inserting the first name, the head is changing, because earlier head was empty, now head is pointing to a new node. So this is head, and let's also declare head here, and we call it node star head equals to null. Now we can see kind of our algorithm we have converted into code, just that we have to write one function, and also we have to return head after we have inserted all the names, because return type of this function is node star. Fair. So now we have to write insert sorted. So let's go here. Insert sorted function will return node star. It will take a head, and then it will take char name, and let's write this function. Now before we can insert any node in the linked list, we should first allocate the node. So let's do that. Node star, or let's first write that comment. Allocate node, put name in node. Node has next and previous, set next and previous to null. So this way we will have created a node. Now after the node is created, find the right place and insert the node. After we have inserted the node, we will return the new head. So this is what we have to do. It will be either new head or the old head that we got. Fine, so let's start with allocating a node. Node star n is equal to malloc size of node. Okay, node allocated. Then put name in the node. Now name is a string because it's a character array. So if we have to copy this character array into another character array, we know we have to use string copy. strcpy n of name of animal. Typically we should copy it by double click here, control C, double click here, control V, so that we are not making any typing mistakes, comma name. So this will copy, this will put the name in the node. Let me write it with comments. Now set previous and next to null. So we say n of next equals n of previous equals null. Okay, that also done. Now we have to find the right place for n. We have to insert n in the linked list. Now we have to think about all the cases. We might be inserting in the beginning, we might be inserting in the end, and we might be inserting in the middle. So we will be inserting in the beginning only in two cases, and the first case is if original linked list is empty. So if head was null initially and we are inserting a node, then the new node that we are inserting becomes the head. So take an example. If head is blank, head is pointing to null, and after that we say insert cat in it. So what we will do, we will create a new node which is these three steps, and we'll put cat here. Previous we will keep null, next we will keep null, and we will say now this new node is the head. So head will be pointing to this. Previously it was null, now it becomes this. So let's write this code to have this effect. So check is if head equals to null. That means if list is empty, we simply say the new node is the head, because we have to return the new head back, and new head in the main will be assigned to this value head. So head gets updated here. So this is empty list case. Now let's look at second case, that is insert in beginning. Now this case is the case where we talk about if we in the linked list, if we had, let's say cat already is there in the list, and this is where head is pointing right now. Previous is null, next is null. Now if we are inserting bear, so what we will do, we'll create a new node called bear, which will have next and previous pointer. Then in order to insert that, we will establish a link next of n will be pointing to h, because this is our n, this is our h. So first change we will do is n next equals to h. Second, what we will do is h previous, which was null earlier, now we will say h previous is equal to n. So we establish a backlink, and once we have done that, we will say now the h will point to this. H will no more point to this because our head node has changed. So h will come here, that means n is becoming the new head, and we will return n. Let's convert this discussion into code. So we go down again. So inserting in beginning, first we should know whether we should insert in the beginning. So that we will check if string compare of current name that we are inserting, if our current name is compared with head name of animal, okay, it came there, head and name of animal. If when we compare these two strings, if our first string is less than the second, then string compare will return a negative value. So what we will do here, the conclusion is our name is less than name of animal. That means bear is less than cat. So what we will do in that case, we will say n next equals h head, head previous equals n, and after doing this thing we will say return n, because n is the new head. So insertion in beginning, this is the only case when we will do insertion in the beginning. Now rest of the cases are insert in end or insert in middle. So if we have to do insertion in middle or insertion in end, we have to search for the right place for the node. So let's consider one more example there. So if bear is there, dog is there, bear is pointing to dog, dog is pointing to bear, dog next is null, head is here, bear back will also be null. So now if we are talking about inserting cat, so what we will do is we will first create a new node called having a value cat. It's previous and blank will be next will be this. This is our n, this is our h. So we will compare the content of n and content of h. So when we compare using string compare, we will see which one is smaller. So if h of name is smaller, like if bear is smaller than cat, we will move ahead. So we will take another pointer called current pointer, which first will come and compare bear with cat. So this comparison happens. If name of c is less than name of n, we move forward. Move forward means C moves here. This is our current node. So after C moves there, again we do the comparison of N with C. Now if we do the comparison, now dog is not less than cat. Dog is greater than cat. So what should happen is cat should be inserted before current. So cat should be inserted somewhere in the middle. If we are saying cat should be inserted in the middle, we should bring the current. Okay, we should have the previous of current in another variable P, because previous of next will point to N, N previous will point to P, previous of C will point to N, and N next will point to C. So these four adjustments we have to do. So let's go ahead and write that code. So what we will do is we will take node star C star P, two variables we are taking. Initially let's see be there on head. They say while C is not equal to null. So what we do, we compare the content of C and our name that we are interested in inserting. So we compare and we say if strcmp, if the name is compared with current element, if name and current name of animal, if the name we want to insert, let's say we are inserting cat, if our name is less than, if our name is greater than the next name, so what we should do, we should move forward. So that means we are comparing bear and cat. So cat is our name that we are inserting, which we are putting first. Bear we are comparing it with, which is in current. If our name is bigger than bear, we will move ahead. So if this case happens, then we say C equals C next. Or we can say if our name is smaller than the next name, let's do it the other way. If the name we are inserting is less than the other name, what we should do, we should do insertion here. So here we can say do insertion here. Otherwise every time we will keep on moving forward. Moving forward is C is equal to C next. That's it. Now let's see, we have found a node from which our name is smaller. So kind of example here is, here there is dog and we were inserting cat, and initially there was bear. So when C reaches here, our name cat will be smaller than dog, and if it is smaller than dog, what we should do, we should do the insertion somewhere here, which is before C. So before C we are doing the insertion. So first thing we will do is we will preserve P. So we say previous equals C of previous. Now we go back to previous. So we have previous, we have current. Let's say we have to insert N between previous and current. So we will say previous next equals N, because previous we have, current we have, next we are inserting in the middle. So this is one change, this is another change, this is one change, this is another change. 4 arrangements we have to do, and in this case head will not be changing. Whatever was the original head, that is what we have to return, because we are inserting in the middle. So we come here and we say previous next is equal to N, N previous equals to P, then current previous equals N, and N next equals to current. These 4 things are done, and we have done the insertion. Now after the insertion is done, here itself we can return head. So we have handled insertion case also. Now think about the insertion in the end. If we had cat, if we had dog, and we are inserting zebra, so what will happen is, in this loop we will never find a value from which our name is smaller, because zebra will not be smaller than this, it will not be smaller than this. After that C will become null, because this loop runs till C is not null. Now once C becomes null, we come out of the loop and we have not done the insertion. So we come here only when C is null, because if C doesn't become null, loop will continue and we will be finding the right place, and in case we find the right place we return from here, and once we return we can't move ahead in the function. So we are here when C is null, we know we have to insert in the end. Now how do we insert n in the end of the linked list? To insert in the end, we should know the last node of the linked list, because cat dog C comes here, which is null after dog next. Now if we had someone who is pointing to dog, we could have simply inserted here. So previous that we declared, let's use previous to give us the previous node. So what we will do is, before we change the C to next, we will say P is equal to C. So this is keep a backup copy of C before changing it. The benefit of doing this will be that we will have P pointing to the last node when C becomes null, because C is equal to C connects will make it null if we are on the last node, and P will be pointing to the last node. So here once we come, then we say P of next, because P is the last node, we say P of next is n of previous is equal to P. That's it. So this is insertion in the end case, this is insertion in the middle case, and on top it was insertion in the beginning case. And with that, mostly we have solved the problem. Now we should check if our solution is working. So let's do a run code. Run code typically runs the sample test case with our code, and we can see it is saying congratulations, your test has passed. So one test case, which was a public test case, this is the input for that, this is our output, this is expected output. Whenever our output matches expected output, we say our test has passed and accepted. Now we are ready to go and do the submission. So let's do the submit code. It says, are you sure you want to submit? We say yes. Now when we do the submission, it is running some test cases which are hidden from us, which are not known to us right now. Some inputs are given at the time of setting the problems. So we can see our code is passing all the test cases, and that tells like we have solved the problem successfully. Cool. So the main tips, if we quickly summarize, is our goal when we are solving a contest problem is to convert any given input to output. Now in order to do that, some problems may ask us to write the complete code from scratch, or some problems ask us to write the partial code like this. Some code is already given and we have to write some code. Now this code we have to make sure we are reading the input in correct way and we are generating the output in correct way. And another tip was we should never use the printf statements for taking user input. We should always assume this input will be given to us automatically. Someone is typing this for us and we just have to read that. Well, that was the solution of first problem. We'll also be releasing solutions to the next problem. So thanks for watching. See you in the next video. Bye. Have fun.